Hello everybody. We are Group 9 for course EECSE6893 Big Data and Analytics. Our project topic is factors affecting the movie grossing and the movie gross predictions. Next page, please. The goal of our project is to make a user-friendly user interface for people, especially the movie investor, to use our prediction models for the novelty. We crow the movie data in the box office and the IMDb website and combine them to existing datasets. So others could also use our open source code to crow or combine their own movie data. And we analyzed the relations between movie sales and some factors including movie release date, movie genre, runtime, and IMDb rates. And we also will provide some visual analysis from 2010 to 2022 and predict the movie predictions for movie providers with some relevant informations about movies in our eventual websites. Next page. And the data source of our project consists of two parts. The first part will be the Crow datasets, which is Crow by us using the Python program from some qualified website like Box Office Mojo website. And we have some existing datasets download from IMDb open datasets. We eventually combine them together to get our own self-designed datasets. Such datasets has high volume, having 200 movies a year and 2,400 movies in totals, and we will update the data daily to keep these high velocities. Last but not least, the movies will have 22 categories and 12 feature columns that guarantee our data's high varieties. The difficulty of data processing is that we will most likely to remove the data outliers, drop the column or rows with missing values, and we would like to match the movie's t constant or n constant, which is a unique integer numbers for each movies, and then we will need to combine many data sets with various t constant and n constants. Next page.
For the technology and system part, you can see two columns. The left one is the technology we used according to the steps, and the right one is system design. But we will only focus on the picture in the right side right now. First, before storage, there are our data collection steps, which we discussed in the previous slides. After that, we did visualization and machine learning in the Jupyter Notebook to meet our goals. Then we designed a web app by using Flask and Bootstrap. Next page, please. Now we will go deeper into technology details. First, for the dataset, we use Python files called crawl and combine to get dataset. Second, for the visualization part, we use pandas, numpy, matplotlib to process data and generate graphs. Then, for the prediction part, we use machine learning to predict our results by using 7 models, and we will see them later. Finally, we use Flask and Bootstrap to generate our web page and deploy it to the GCP. Next page.
Here's our visualization process. We finally got 8 graphs as results, which are IMDb rate distribution, which is a bar chart to show the count of the IMDb rate, which is a bell-like figure, which shows accuracy of the IMDb rate we got. And also we have movie genre proportions, shows percentage of each movie genre. And also we have the runtime distribution is also a count of the runtime. And also we have bar charts like top 20 directors count, and also we count the top 10 gross, and also the highest movie gross. And then we have the heat map as IMDb rate with year. And finally, we got the word count at the to count each genre and show them as a word count map. And here's our prediction. First, we do the data processing. We deal with invalid data in the data set, which means we remove all the invalid data like the outliers and some null data. And then we convert the original data type to int, float, and list because the model only accepts the numbers. And we apply one hot encoder to title and directors. By applying the encoder, we transfer the strings from title directors to the numbers. And by doing the encoder, we have expand the features of each movie. For each movie, we finally got like 3,000 features for each movie. And then we feed these inputs into the models and compare the accuracy of each model. Here's the results we got. These are the errors, different kind of errors of each model. We can see that XGB regressor, which is the XG booster, had the lowest error from each kind of error. And so finally, we choose XG booster as our default model to do the training and the prediction. Here's our website. So we use Flask to deploy our website, and we use Bootstrap to build our front end. And then we deploy the website on GCP. Here's a link to our website. And we also build a prediction page, which users can input their own data, movie data, to predict the movie growth. And I will demo our website. Okay, here's our website. We firstly get started and has show our goal and novelty and has some summary about our technology used in the system design. And then listed the data set we used and how we get the data set. And here's a link to our GitHub repo to check the codes. And here's the visualization parts for each graph. We have the title and some explanation of each graph, and we can zoom into the graph to see the details. And then finally, we got the prediction part. Let's predict our movie. Let's do a demo here. For example, I create a movie in 2022, and the title is maybe I can call it My Movie. And the IMDb rate, I want the IMDb rate to be like 8.6, and the runtime is about 100 minutes, and the genre is maybe it's an action movie and an animation and also a comedy. The directors, let's input my name and submit. Wait a few seconds, the prediction results will show here. Okay, here's the results we got. The predicted growth of my movie is about this month. So here's our project, and thank you all for listening.